Hello students, in the previous lecture we have started with the topic detailed drawing of universal coupling. In the previous video we have seen the various components of the universal coupling. Today we will be starting with the detailed drawing. We will draw each and every component, that is we will draw the sectional front view and top view of the different parts one by one. Now let us see the figure. The first part that has to be drawn, or the first detailed drawing will be drawn of the first part. Here you can see the first part. Now what was the first part? Now the first part from the part list is the fork. So we have to draw the sectional front view and top view of the first part, that is the fork. Before drawing the sectional front view and top view, first we will identify the fork. So this is the first part. You can see here this arrow has been pointed, so this is my first part, that is the fork. Now we will first identify the dimensions of the fork, that is what is the length of the fork, what is the height of the fork, and from the top view we will identify what is the width of the fork. This is the top view of the vertical fork. This figure from here to here is nothing but the top view of the vertical fork, whereas this figure, that is this portion in which section line has been shown, is nothing but the front view of the vertical fork. Now we will see the total length of the fork. Now the total length of the fork is given here. You have to add these all values, that is 38 plus 44 plus 30 plus 56. So if we add this all value, we will get the total value as 56 plus 30 will be equal to 86. 86 plus 44 will be equal to 130, and 130 plus 38 will be equal to 168. So the total length of the fork is equal to 168. Now we will identify the height of the fork. Now the height of the fork will be the length from this point to this point, and it is given as 166 mm. So the length of the fork is equal to 168 mm from here, that is this point, to this point, and the total height of the fork is equal to the length from this point to this point, that is equal to 166 mm. Now we will identify the width of the fork. Now the width of the fork from the top view can be seen as, now the width is equal to the distance from this point to this point, that is this distance. Now in the top view the width is not given, so we have to find the width from the front view. You can see here the width of this figure, that is this figure, or the top view of the vertical fork is not given, so we will identify the width from the front view. Now in the previous lecture I have said you that the top view of the vertical fork will be same as the front view of the horizontal fork. So this is the front view of the horizontal fork, except that in the front view we have shown the section lines. So you can see the width of the fork is equal to 88. This is nothing but the width of the fork. So the width of the fork, that is from the distance from this point to this point, will be equal to 88. Also in the front view you can see here on the right hand side, the width from this point, that is this point to this point, will be equal to 88. So the width of the fork is 88. So finally we have identified all the dimensions. The length is 168, the height is 166, and the width in the top view will be equal to 88. And the total length from this line, that is this line, to this point, that is this length, will be equal to 168. It is directly obtained from the front view, so the length will be remain the same. The total distance from this point to this line will be equal to 168. Now also the fork has a hole inside it. Now you can see a center line is passing through the fork. This is a center line. Now the center line is drawn at a distance of 38 from the end. So from this line, that is this end, you have to mark the center line, which will be at a distance of 38. Whereas the horizontal center line, that is this center line, will be dividing this fork into two equal parts. So we can say that this center line will be passing through the center of the vertical fork, that is it will divide the fork into two equal halves. Now let us start drawing the front view of this vertical fork, and after completing the front view we will draw the top view of the vertical fork. So in the first step we will draw the front view inside a box. So first we will draw a box. The box will have length equal to 168, whereas the height of the box will be equal to 166, as we have identified the dimensions from the figure. So now we will draw a light box. The box should be light. So we will draw it with the help of faint lines. So first I will mark the distance 168. You can see 168, and the height will be equal to 166, since we have identified the length as 168 and height as 166. Again, now we'll complete the entire box. So the length again will be 168 and the height will be equal to 166. So we have completed the box. So this is the box I was talking about. Now I will give the dimension so that you can see here the total height was equal to 168. You can see the dimension 168, whereas the total length of the box is equal to 168, because this was the length of the vertical fork. So the total length is equal to 168 and the total height is equal to 166. Now first we will mark the center line of this box. Now the fork is divided by the horizontal center line into two equal parts. So we will divide this box horizontally into two equal parts by drawing the center line. So this is the midpoint. You can see this is the midpoint of this line. You have to first locate the midpoint of this vertical line of length 166. So you can see this is the midpoint. Now I will draw from this midpoint. You have to draw a center line, horizontal center line. So I have drawn the horizontal center line, which is at a distance of half of 68. Now we have to draw the vertical center line. Now in the figure it was clear that the vertical center line, that is this center line, you can see this center line is at a distance of 38 from the left end, that is the left end of the box. So in order to draw the vertical center line, first we will mark a distance of 38, that is from this left end. This is the left end of the box. From this end we have to take a distance 38 towards right hand side and then draw the center line. So now we will draw the center line at a distance of 38. So now I am drawing the vertical center line. You can see here this is the vertical center line at a distance of 38. Okay, this is not coming straight. I will draw it. So we have drawn the vertical center line also. Now I will show the dimension of this vertical center line, which is at a distance of 38. So from the left end we have to take a distance of 38, so as to mark this center line. Now we will give the dimension of this center line. So you can see this center line, that is this vertical center line, is at a distance of 38 from the left hand side. So we have drawn the horizontal center line. This horizontal center line divides the box into two equal halves, whereas this vertical center line is at a distance of 38 from the left hand side, because it is given in the question. Now in the next step we will start the drawing of the front view. For that we will see the figure. First we have to draw this line, that is this straight line. This straight line from here to here is of length 38 plus 44 plus 30. So we will add all these values. We will get 38 plus 44 will be equal to 82, and 82 plus 30 will be equal to 112. So the length from this point to this point is equal to 112. So in the first step we have to draw a straight line which will be of length 112, both on the upper side as well as on the lower side. You can see the same line is present here also. So the length from this point to this point is equal to 112. Similarly the length from this point to this point is also equal to 112. So now we will draw. So I will select the line. Now from this point, that is the first point. Okay, first I am deleting these dimensions. We can give it later on. I have given a dimension so that you can understand. Now we will give this dimension later on after completing the entire sectional front view. Now I am zooming the diagram so that you can understand. Now first we will draw a straight line from this point of length 112, 112. So you can see now I have drawn a straight line of length 112 mm. Now I will give you dimension so that you can understand. So this line is of length 112 mm. Similarly we have to draw the same line at the bottom also, which will be of length 112. So again I have drawn a straight line at the bottom which is of length 112. Now I will give the dimension. You can see the dimension will be equal to 112. So we have drawn this line of length 112 mm. Now this 112 mm we have obtained from this figure, that is 38 plus 44 plus 30. So the total length was equal to 112 mm. Now next, in the next step, we will draw this vertical line from the left hand corner. This vertical line is of length 30 mm. You can see 30 mm. So we have to draw this vertical line of length 30 mm. Similarly, from the bottom also we have to draw a vertical line which will be of length 30 mm. So in short, we have to draw vertical line from the top and vertical line from the bottom. Both will be of length 30 mm, 30 and 30. So in the next step, now we will draw vertical line of length 30 mm. From this point we will take a length of 30 mm. Again, from this point we will take a length of 30 mm. Now we will give the dimensions. See, you can see the dimension will be equal to 30 mm. So we have drawn a line of length 30 mm. Again, we have drawn a line of length 30 mm. So two vertical lines from above and below of length 30 mm. Now in the next step, we have to draw these two lines, this vertical line from here to here and this vertical line from this point to this point. So in order to draw this vertical line, first we have to identify the dimension of this vertical line. Now what can be the dimension of this vertical line on the above side and this vertical line on the below side? Now you can see the total length of the vertical fork is equal to 166, whereas the length of this part, that is from hub, we can say this part is nothing but the hub of the vertical fork. The length from here to here is equal to 1, is equal to 88. Students, here some printing mistake is there. This dimension is not till here. This 88 dimension is from this line to this line, that is this hub will be of diameter 88. So you can correct this line has to be represented here. So the total length is equal to 188, whereas the dimension of this middle part is equal to 88. So in order to get this dimension, we have to subtract 88 from 166. So if we subtract 88 from 166, we can get the value as equal to 66 plus 12, that is 78. So if I subtract the value 88 from 166, I will get the value as 78. Now there is half line on the upper part and half line on the lower part. So in order to get this dimension, we will divide the value obtained after subtraction, that is 78, by 2. So we will divide the value, that is 166 minus 88, which is equal to 78, and 78 divided by 2 will be equal to 39. So this line, that is upper half, will be of length 39 mm, height 39 mm, and this lower part will also be of height 39 mm. So now we will draw vertical lines from this point and this point, which will be of length 39 mm respectively. So from this point I am drawing a vertical line of length 39 mm. Similarly, from this point also I will draw a vertical line of length 39 mm. Now we can see the dimension. I will give the dimension here. So this line is of length 39 mm. Similarly, this line is also of length 39 mm. So we have drawn vertical lines of length 39 mm. Now in the next step, just we have to draw horizontal line till this end line of the box. Just draw a straight horizontal line till this end line of the box. So now from here to here we will draw a horizontal line, and finally we will join these 2 points by a straight line. So we have joined these 2 points with a straight line. Now we will see this dimension. Now this dimension has to be 88. The total length was 166, whereas the diameter of this hub, this central part, was equal to 88. Now we can check the dimension whether it is right or not. So see, we can see here the dimension is 88. So this diameter is nothing but equal to 88. Now we will give the dimension here. So it is nothing but the diameter. So this was the diameter equal to 88 mm. You can see this from this figure. This dimension of this part, that is the hub, is equal to 88. So we have obtained the right dimension. Now in the next step, what we will do, we will draw this line, that is this horizontal line. You can see this horizontal line. Now this horizontal line is of length equal to 38 plus 44. You can see the dimension is given as from this point to the center, it is equal to 38, and from this center line to this point, that is this corner point, the dimension is equal to 38 plus 44. So the total dimension from this point to this corner will be equal to 38 plus 44, that is equal to 82. So we have to draw a straight line that is of length 82 mm. So now we will draw a straight line of length 82 mm from this point. So this is of dimension 82. Again on the bottom side also we will draw a line of length 82 mm. Now we can check the dimension. So this has to be length 82, you can see 82, and this will be also of length 82 mm. So we have drawn the line of length 82 mm. Now I am deleting these extra dimensions which are not needed now. So we have drawn horizontal straight lines of length 82 mm and on the above side and on the below side. Now we will simply join the end of these two lines. You have to join these two endpoints by drawing a straight vertical line. So we are joining this point. So finally we have joined the line. Now this line should be of length. Now we will obtain the length from the figure. You can see the distance from here to here, this distance, this vertical distance from this point to this point should be equal to 106. You can see the distance is given as 106. So the distance from this point to this point is equal to 106, or we can say the length or the height of the center block is equal to 106. So now we will check whether we have drawn the line with the dimension or not. This should be equal to 106. Now we will check the dimension. So from this point to this dimension is equal to 106. So we have drawn accurately. We have drawn the line of length 106 mm. Now in the next step we will draw the holes which is present inside the fork. We will draw the holes which is present inside the fork. Now the holes will be, in order to draw the holes, first we have to identify the dimensions of the hole. What are the dimensions of the holes that are present inside the fork? Now we will see the figure. Now you can see this hole or the pin is passing through the fork. Now the pin is of diameter 30 mm. So if we want to insert the pin inside the fork, that is this part, and if the diameter of the pin is 30 mm, the hole inside this fork should also be of diameter 30 mm. So first we have to draw a hole of 30 mm on the upper side, and same hole will be on lower side also, since the pin is of diameter 30 mm. Now the center of the hole is at a distance of 38. So we have already marked the center line. So from this center line you have to mark or draw a hole with diameter 30 mm. So 15 mm towards left and 15 mm towards right. So now we will draw the hole with dimension 30 mm. That is, diameter of the hole is 30 mm. So now we will draw from this center. You have to take 15 mm towards right, as the hole was of diameter 30 mm. So 15 mm towards right, and then we will complete the vertical line. Again we will take a distance from the center. This is center, 15 mm towards left, and then we will complete the cylindrical hole. So this hole will be of diameter 30 mm. Now we'll check the dimension. So you can see, okay, the dimension is wrong. We will check it again. This has to be of 30 mm. So some mistake is here. Now we will check where is the mistake. So the length from center to the end should be equal to 15 mm. So this length should be equal to 15 mm. So this is right. Now the second length from here to here should also be equal. So this is wrong. We have to change the dimension. So now we will again draw a straight line at a distance of 15 mm from the center. This is the center, and now we will take a distance of 15 and we will draw the line to represent the hole. Now again we will check the dimension. Now if we check the dimension of the hole will be equal to 30 mm. So we have drawn the hole to which the pin will be passing, and it is of diameter 30 mm. Similar hole has to be drawn on the bottom side also. So again we will repeat the steps. From this center line, take a distance of 15 mm towards right, 15 mm distance towards right. Okay, from this center we will take a distance of 15 mm on the right hand side, and then we will complete the vertical line. Again, from this center line we will take a distance of 15 mm towards left hand side, and then we will complete the hole. Now we will check the dimension of the hole. It should be equal to 30 mm. So we have completed the hole which is of diameter 30 mm. Now this hole will be visible after taking section, so we have drawn dark lines. Now in the next step we will draw the hole which is present inside the hub. Now this hub will contain a hole for inserting the shaft. Now you can see in this question, this shaft which is of diameter 50 mm is inserted inside the vertical fork. This is my vertical fork. Now inside this vertical fork I have inserted a shaft which is of diameter 50 mm, and above that we have inserted a key which is of height 10 mm. So here there should be a hole or a slot so that we can insert both the shaft as well as the key. So first, for inserting this shaft we should have a hole which is of diameter 50 mm. So from this center line we have to take a distance of 25 mm above and 25 mm below, so that we can insert this shaft inside this vertical fork. So we have to draw a hole of diameter 50 mm. So now we will draw a hole of diameter 50 mm. So from this center to take a distance of 25 mm above, and then we will draw the line, straight line till this point, and again from this point to take a distance of 25 mm below, and then we will draw a straight line to complete the cylindrical hole. From this center point we will take a distance of 25 mm below. Okay, this is the point. We will take a distance of 25, and then we will draw a straight horizontal line till the end. So this hole is drawn or is created so that we can insert the shaft inside it. Now as per the figure, the diameter of this hole was 50 mm. Now we will check it. So you can see the diameter is what, 50 mm. So we will give your dimension. The diameter is equal to 50 mm. So finally we have got the dimension as 550 mm. Okay, I am deleting this. We will shift this line here, and this hole is of diameter 50 mm. So we will give the dimension here 50. I will insert the diameter symbol here. So we have given the dimension of this shaft hole, which is equal to 50 mm. Now after completing the shaft hole, now we will draw the slot for the pin, or the extra hole which has to be drawn for the pin. Now you can see in this figure, the total height of the pin is what, 10 mm. The total height of this pin is equal to 10 mm. Now out of this 10 mm, a height of 5 mm will rest inside the shaft, whereas a height of 5 mm will rest inside the fork. So it means that the total hole for the pin should be of height 10 mm, since the pin is equal to height of 10 mm. But out of that 10 mm, the 5 mm hole will be present inside the shaft. A 5 mm slot will be present inside the shaft, whereas the 5 mm hole, or the hole of height 5 mm, will be present inside the fork. So we have to draw a straight line. There is this line which will be at a distance of 5 mm, so as to represent the hole for the pin. Now we will draw that. So from this line we have to draw a line at a distance of 5 mm above. So now we will draw the line at a distance of 5 mm from, so from this point take a distance of 5 mm above, and then draw a straight line till here. So you can see these two lines are spaced at a distance of 5 mm. Now we'll give the dimension so that you can understand. So you can see 5 mm. This is because 5 mm of the key will go inside the fork. So we have to create a hole or a slot of height 5 mm, whereas the remaining 5 mm will go inside the shaft. So we have drawn the slot for inside the fork which is of height 5 mm. So finally we have completed the front view of the vertical fork. with the pinholes inside it and the shaft hole and the key slot also inside it. Now we will give the dimensions. So from here, okay, I will delete this first dimension. I will delete this dimension. So now we'll give the dimension. So the distance from here to here in the question was given as 38. So we have obtained a distance at 38. Now the next distance from here to this point was, I think so, it was equal to 44. We can check this figure. So you can see the distance from this center line to this point is equal to 44. So now we will give a dimension. So the distance from this point to this point is equal to 44. So we will give the dimension. Okay, we will give the dimension. So from this point to this point, the dimension will be equal to 44. You can see the distance from this point to this point is equal to 44. Now the next distance from this point to this end line we will give here is equal to 30 mm. So now we will give a dimension from this point to this point. So now we are giving a dimension. This is my first point and this is my second point. So you can see the dimension as 30 mm, which was given in the question. You can see here the dimension is 30 mm and the last distance is 56 mm from this line to the end of the box. So 56 mm. Now we will give that dimension also. So from this point we are giving a dimension of this point, that is the end point, and it will be equal to 56 mm. So we have given all the dimensions. Now the total height was equal to 166. In the question it was given the total height is equal to 166. Now we will give this dimension also. So I am giving the dimension. You can see from the total height from this point to this point is equal to 166. So we have given the total height also, the total dimension, that is equal to 166. And the last one is the pinhole. Now this pinhole was of diameter 30 mm. So we have given a dimension as 30 mm. So we have completed the front view of the vertical fork with all the dimensions given. Now this is what sectional front view. So we have to show section lines inside it. Now this part and this part is a hole, so section line will not be present inside the hole. Similarly, this upper part of height 5 mm is a slot for the pin or the key, so this is a hole, and this is a shaft hole of diameter 50 mm. So inside holes we never show the section lines. We have to show the section lines only in the solid part. So this part, this part, this and this are solid parts. So now we will show the section lines inside the solid parts. So this is my solid part. I will show this is solid part, this is a solid part, and this is a solid part. So we have shown the section line inside the solid part. So finally we have completed the sectional front view of the vertical fork. Now we will complete the top view. Now in order to complete the top view, what we will do, first we will draw a box. Again we will draw a light box of dimension. The length will remain same, that is equal to 168 mm, whereas the width will be equal to 88. I have told earlier that the width will be equal to 88. You can see from this figure the width will be equal to 88. This is nothing but the width. This width from here to here will be equal to 88 mm, and it is obtained from the front view. You can see this distance 88. Similarly, this distance is also what, 88. So the width in the top view will be equal to 88 mm. So now we will first draw a box, light box in the top view of length 168 mm. The length will remain same, that is from here to here will be equal to 168 mm, whereas the width will be equal to 88 mm. So now we will draw a box, light box. So I will project, I'm projecting this end point. So first point is this, and towards the end I will project this end point. So I am projecting the end point, that is this end point. This is the end point of the fork. So we have marked the length. Now this length will be equal to the length above, that is equal to 168. So just you have to project it. We can check also, if you want to check it, you can see this length will be equal to 168. So just project the end point, that is this point in downward direction and this point in downward direction, you will get the length directly. Now we will mark the width. Now the width was equal to 88, so we have to draw a vertical line of length 88 mm. Now you can see this vertical line is of length 88 mm. Now I will give you the dimension so that you can understand. From here to here the width is equal to 88, so you can see the dimension as 88. Now we will complete the entire box. So from this point, this end point, again I will draw a line of length 168 to represent the length, and finally we will complete the box. So we have completed the box in the top view. This will be of width 88 and the length will be equal to 168, that is this length. The total length will be equal to 168. If you want, I will give a dimension here. So I have given a dimension. The length is equal to 168 and width is equal to 88. Now we will draw the center line. First we will see the location of the center line. Now you can see this center line in the top view is dividing this top view of the vertical fork into two equal halves. So this center line is, or the section line, is exactly passing through the center of the vertical fork in the top view. So we will first draw the center line. So in order to draw the center line, first we will locate the midpoint. Where do we have to locate the midpoint? So you can see this is the midpoint, and from this midpoint you have to draw a straight horizontal center line. So this is the center line in the top view. Now we will draw the vertical center line. In order to draw the vertical center line, you have to just project this center line from the front view. So we will project this center line, vertical center line, from the front view into the top view. So we have projected. So this was the horizontal center line dividing the top view into two equal halves, whereas this vertical center line is the projection of the vertical center line in the front view. Now in the next step, what you have to do, first you can see the distance from here to here is equal to 38. This part is a curved part or a semicircle. Now this is observed from the top view. If we can see, I will this is a center line. Now if we extend this center line, this will match with this center line. You can see in the top view the center line, this center line is nothing but the extension of the center line in the front view. Now from this center line, this part is the curve. This is a curve or a semicircle. This semicircle will be of radius 38. Now you can see the distance from here to here is equal to 38, and this center line, this where 38 mm ends, this center line, if projected downwards, is seen here. So the distance from this point to this center line is equal to 38, and it is nothing but a radius, a semicircle of radius 38. So we have to draw a semicircle of radius 38. So this part of the fork from this line to this center is nothing but a semicircle. It is not a plane surface, it is a semicircle of radius 38 mm. So we have to draw a semicircle of radius 38 mm. For that you have to take this center. Taking this center, you have to draw a semicircle of radius 38 mm. Now we will draw. So I am taking this as a center, and we will draw a semicircle of radius 38 mm. Now you can see we have drawn this a circle. This circle is of radius 38 mm. I will show the dimension here so that you can understand. If we check the radius, you can see the radius is equal to 38. So the radius of this semicircle will be equal to 38, since the distance from here to here is equal to 38, this distance. Now we will erase the full circle so that we can obtain only the semicircle part. So we have done it. Now in the next step, what you have to do, you can see from this figure, we have to draw this straight line. This straight line. Now you see, if we observe this figure from the top view, we will observe this point, and this circular part or this point will represent a straight line. So the top view of this corner is nothing, or this corner is a straight line. This is a straight line. Similarly, the top view of this corner, that is this point, is also a straight line. If we project this point in downward direction, we will get a straight line. So this corner is nothing but the is in top view it will be visible as a straight line. Similarly, this corner will be visible in the top view as a straight line.
So now we will draw a straight line, and this line will be of dimension equal to 88 mm. So now in the top view we will draw a line of 88 mm length. So we will project this point I was talking about, this point and this corner point will be visible as a straight line in the top view. So if we project this point, it will come at this end. So we will draw a line of length 88 mm. For that we will take 44 mm above. So you can see I have taken a distance 44 mm above. I will zoom it later. This distance is what, 44 mm above. Or we can directly draw a straight line. Since the total length itself is equal to 88, so we will directly draw a straight line. So from this point to this point we will draw a straight line, and this will be of length equal to 88. Now I will give the dimension. Now you can see we will give the dimension. This line itself is equal to 88 mm. So we have marked the width because equal to 88 mm. Now in the next step, what we have to do, we have to project this corner. Now this corner again, when seen from the top, will be drawn as a straight line. If I observe from the top view, this corner will be represented as a straight line in the top view. As you can see in this question, this corner this corner is represented as a straight line in the top view. If we project this corner in the top view, it will be drawn as a straight line, and its width will also be equal to 88, because these two lines are parallel to each other and of equal length. So this length is equal to 88, so this length will also be equal to 88 mm. So now we will project first this corner. We will project this corner in the top view. So you can see I'm projecting to the corner. You have to just draw a slight vertical line for projection. The position line should always be light. So now I have projected, and I am drawing a line of length 88 mm. So in order to draw this line, first project this corner. You have to draw a light projection line. Project this corner in the top view, and then draw this line of length 88. It will fit inside this box only, because this box is having a width of 88 mm. And after drawing this line, we will join these points, this, and the next is to be joined this. Students, again I am repeating, first project this point, and it will be drawn as a straight line at top view of length of width 88 mm. In the second step, project this corner, that is this corner point, and it will be visible as a straight line of width 88 mm. And finally complete this rectangle. Now in the next step, what we have to do, now you can see, if I observe this figure from the top view, this corner point will not be visible. These two corners, that is this corner and this corner, were on outside. So if we observe from the top, both this corner as well as this corner will be visible. But this corner will not be visible from the top, because above it a surface lies. This is a plane surface which is lying above this surface. So this corner point is lying below this surface. So if I observe from the top view, this corner will not be visible. So if we see, if we project this corner, if we project this corner in the top view, you can see we have drawn a dotted line, dotted straight line. This is because this straight line which is represented by this corner will not be visible from the top view. So we have to project this corner point in the top view and then draw a straight line which will be hidden. So we have to draw a hidden line for that. So in order to represent this corner in the top view, we have to draw a hidden line in the top view. For that, we will first project it in the top view. So just draw a light projection line from this corner or from this corner. You have to project or draw a light projection line from this corner. And then after projecting, we will draw dotted line from here to here, since that corner will not be visible. So you can see we have drawn a dotted line from here to here, since this corner will not be visible from the top view, because above this surface the second surface comes. That is, this surface comes first and then this surface comes. So this surface or this corner will not be visible from the top. So for this corner, after projecting in top view, we have to draw a dotted line. And finally we will join this point to the end by using a straight line, and again we will join this point to this point by drawing a straight line. So till now we have completed two surfaces, first and second. Now you can see here we have completed this part, that is this rectangle, and we have completed this part, that is this rectangle. Now the last line to be drawn is, you can see the inclined line. Now this line starts from this point, that is where the dotted line is drawn. So at the end of the dotted corner of the dotted line, we have to draw inclined line from this point up to the semicircle. So this line is nothing but tangent to this semicircle. So from this point you have to draw an inclined line which will be tangent to this semicircle. So in the next step we will draw inclined line. Now you can see here I am zooming out. From this point you have to draw a line tangent to this semicircle. It should be tangent. Students, note that if I draw the line in this manner, that is I am joining this point with this end point of the semicircle, it is wrong. We have to draw a tangent line. So you can see here I will draw a tangent line from this point, and you can see I have selected tangent command TAN. So I am drawing a tangent line. You can see it is here mentioned a tangent point, so we are drawing a tangent line. So this line is nothing but tangent to the semicircle. If I show you this part by zooming, you can see this line which I have drawn is not meeting at this end point. It is what, tangential to the semicircle. So we will erase the extra part, that is we will delete this part. So you can see now this line is exactly what, tangential to the semicircle. Similarly we will draw a tangent line in below also. So from this point I will draw a line tangent to the semicircle. You have to draw only a tangent line. So this is my tangent point. I have drawn the tangent line. Now you can see this line is tangent to the semicircle at this point, whereas this extra part of the semicircle, it is below the tangent line, should be erased. So I am erasing this part. So this line is exactly tangential to this semicircle. So we have drawn the curve of the semicircle and the tangent line also. Now I am deleting this dimension, we can give it later on. Now in the next step, what we have to do, we have to draw the top view of the holes. Now you can see we have this hole. This hole, if observed from the top view, will be clearly visible because this is a hole. If you observe from the top view, this hole which is of diameter 30 mm will be visible. So for a hole we have to draw a circle, a dark circle of diameter 30 mm, since it is visible. So now we are drawing a circle of diameter 30 mm. So this circle is of diameter 30 mm. You can check here. I will give you a dimension. You can see the circle is of diameter 30 mm, whereas this outside circle, this curve was of radius 38 mm. You can see the radius 38 mm. I will give the dimension later on. So this inside circle is nothing but the top view of this hole, which is of diameter 30 mm. So since we have given a dimension in the front view, we will not give a dimension again in the top view. I am deleting this. This hole will be of diameter 30 mm, and it will be the top view of what, this hole, 30 mm. Now in the next step we will draw the hole of diameter 50 mm, which is nothing but the shaft hole. Now students, if we observe this figure from the top, this hole which is of diameter 50 mm will not be visible because it is present inside the fork. So if this hole is not visible from the top view, then this hole should be drawn with the help of dotted lines in the top view, or we can say this hole is a hidden hole, and the hole begins from this end and ends up to this line. So you can see we have projected this point or this line here. So this is the end of the hole, shaft hole. So the shaft hole will begin from this line and will end at this line. So now we will draw the shaft hole, which will be a hidden hole of diameter 50 mm. So from the center, take 25 mm distance above, and then we have to draw the shaft hole. Similarly, from the center, take a distance of 25 mm below, and then complete the shaft hole. So you can see we have drawn the shaft hole. Now this shaft hole will be hidden because it is not visible from the top view. Now we can check the dimension. I will give the dimension. It should be of diameter 50 mm only because this is a shaft hole. So this shaft hole was of diameter 50 mm. So this slotted dotted lines should be drawn at a distance of 50 mm. So from the center you have to take distance 25 mm above and 25 mm below. Now in the next step, what we have to draw? You have to draw the top view of this pin slot or the hole for the key. Now what will be the dimension? In the front view we have seen that the total height of this key was 10 mm and the 5 mm was inside the fork and 5 mm inside the shaft. But in the top view we don't need the height, we need the width. Now you can see this is the top view of the key. Now if we observe this key or the keyhole from the top view, this key will not be visible. Only this part of the key which is outside the hub. Now you can see some part of this key is outside the hub. That part will be visible. Whereas that part of the key which is inside the hole will not be visible. So you can see in the top view some little part from here to here has been drawn with the help of dark line. Whereas the remaining part which is going inside is drawn with the help of dotted lines, these two parallel dotted lines, and these two parallel dotted lines are nothing but the top view of the hole which is provided for the inserting this key. So what is the width of the hole? You can see the width of the hole is 16 mm. So from the center line you have to draw a hidden line of 8 mm on the upper side and 8 mm on the lower side. So now we will draw the top view of this slot which is used for inserting the key. Now the slot again begins from this point or this end and it ends here. So we have to represent the key hole from this line up till this line, that is from here to here, with width 16 mm. Now I will show the top view. So from this point take a distance of 8 mm above. Total distance was 16, so 8 mm above. Okay, from this point I have to take a distance of 8 mm above and draw the key slot till the end. Again from this point we have to draw the line to represent the key slot. Now this is nothing but the slot for inserting the key. Now this slot will be of dimension 16 mm. You can see I will give a dimension 16 mm. So this slot which is used for inserting the key is of dimension of width 16 mm. So from the center line you have to take distance of 8 mm above and 8 mm below. So finally we have completed the sectional front view and sectional top view of the first part, that is the fork. Now we will give some dimension which are remaining. So I will give the dimension of this semicircle which is equal to 38 mm and the dimension of this circular hole is equal to 30 mm, which is given in the front view. So finally we have completed the sectional front view and sectional top view of the first part, that is the vertical